Welcome. We are going to perform an experiment for the output power of a helium neon laser versus the tube current. We have already mentioned this in our text that in the case of helium neon laser, if you increase the tube current or the ionization current, as the case may be, the inversion will increase because electrons from the excited state of helium will go to that of neon, and they will come down to E2 state, giving us 632.8, and then they will dissipate into the ground state. However, because this is a 4-level laser, there is another terminal level which in between the ground state and the lasing state. So therefore, what happens is that if you increase the current, if you increase the tube current, then as the temperature increases, the E2 level will be populated from the thermal electrons from the ground state. We have discussed all these things. So what we are going to show here is that we have a helium neon tube which is removed of all its cases and all that. So we have a bare helium neon tube, and then we have a 110 volts power supply, and this power supply can be connected to the anode and cathode of this laser, and then we have a resistance box with which we can change the resistance in the circuit such that we can reduce the current, and by reducing the resistance slowly, step by step, you can increase the current inside the tube such that the power output will be there. And correspondingly, with a milliammeter, we can measure the current also. This is a fairly straightforward and simple experiment. What we were saying is that if the current is much lower, then it is necessary for the G sub A to be at least equal to 1. That is, as long as the gain is less than 1, the laser is not going to operate. That's what you will see, that the laser will be flickering. You can see right now the laser is in that state because very low current is there. Now, if we go on reducing the resistance and increase the current, what will happen is that this will become steady and the power will be slowly increasing. We can put a simply detector here and measure the power also, so that we can draw a graph between the power output and the tube current. So, but as I mentioned also in the text, they already have got a resistance here such that you are not allowed to go beyond 6 milliamperes. So therefore, you can get only curve up to the top and not of that. So the experiment simply consists of letting the current first be very slow, and then you can have the measurement of the power and the milliamperes. You increase slowly the voltage to the tube, so therefore the current will increase, and then the power output will increase. But at some point, it simply stops. That's because at that point, E2 starts getting populated and the inversion becomes less, therefore the power output is less. So therefore, this experiment simply shows that as you completely go on increasing the tube current, the power output does not increase. So at some point it increases, and then at a cutoff point it starts decreasing. That's the fundamental things of this experiment.